Today, we are given a problem. The problem says if 3 raised to power x times 5 raised to power x squared is equal to 15, what is x? Right, so I think there are about 2 methods for which we can use to solve this particular problem. The first method is method of direct simplification, and then we could also apply logarithm on both sides of the equation to be able to get the solution right. So let's delve into the problem. So solution. So we have 3 raised to power x times 5 raised to power x squared is equal to 15. All right, like I have always told us, when it comes to simplification or to solving a particular equation, what we do is you try to express the right hand side to look like the left hand side of the equation, right? So this is first method. All right, so we have this one as method 1. All right, so method 1, we use direct simplification. So what we are going to do here is I rewrite this expression, all right, as x times x times 5 raised to power x squared. I can also write it as, instead of 15, I express it as 3 times 15. Since 3 times 5. Since 3 times 5 gives us 15. All right, divide both sides of the equation. Divide both sides by 3 times 5. All right, divide both sides by 3 times 5. So if we do that, that's going to give us 3 raised to power x times 5 raised to power x squared divided by 3 times 5 is equal to 3 times 5 divided by 3 times 5. All right, when we do this we cancel this, and that's going to give us 1. So we have 3 raised to power x times 5 raised to power x squared divided by 3 raised to power 1 times 5 raised to power 1. The result is equal to 1. I'm sure you're still very conversant with this sort of result, okay? So what we are going to do is, in indices, all right, in indices, if you have x raised to power a divided by x raised to power b, what this one means is x raised to power a minus b. So if we apply the law, what we are going to have is, I have 3 raised to power x minus 1. This result is equal to 1. And then again, we should also recall that if you have x raised to power 0 in indices is 1. So we could rewrite this expression as 3 raised to power x minus 1 times 5 raised to power x squared minus 1 is the same thing as 3 raised to power 0 times 5 raised to power 0, because this is 1, this is 1. 1 times 1 is still going to produce 1. Okay, when you solve this type of problem, you will have to be very conscious of what is happening at the right hand side and what is happening at the left hand side at the same time. So what we are going to do here is, if this is multiplying by this and this is multiplying by this, I would be correct to split this equation into 2. So I could, the first case 1, is when I have 3 raised to power x minus 1, I equate it to 3 raised to power 0. Of course, what this means is that since the bases are the same, I could write it as, therefore, my x minus 1 is equal to 0, or I could just simply say x is equal to 1. That produces the value of x. The case 2, um, I have case 2. So the case 2, I have 5 raised to power x squared minus 1. All right, the result is equal to 5 raised to power 0. What that means is that my x squared minus 1, since the bases are corresponding, the result is equal to 0. So my x squared, this is looking like difference of 2 squared, because I could express this as x squared minus 1 squared is equal to 0. So if I take the expansion of that, x plus 1 into x minus 1 is equal to 0. Therefore, my x is equal to 1 or minus 1. But this minus 1 is not a true value for x. So what this tells us is that in any of the cases, the results for value of x is equal to 1. Therefore, we can say that the true value for x is 1. I want you to smile, for mathematics is fun. So we've seen how this first method went. So we are going to look at the second method. So I choose to call this method as method of logarithm. All right, using logarithm. All right, we bring the question down. 3 raised to power x times 5 raised to power x squared equals 15. All right, we could express 15 like we did before. 5 raised to power x, 3 raised to power x times 5 raised to power x squared equals 3 times 5, or 3 raised to power 1 times 5 raised to power 1, meaning 15, right? So we take logarithm of both sides. Take log of both sides. So we have the logarithm of 3 raised to power x times 5 raised to power x squared equals the logarithm of 3 times 5. So we could separate them, because the law of logarithm says that if you have log p times log q, you could write it as log p plus log q. So we apply this to both sides of the equation, and that's going to be very interesting. So we have log of 3 raised to power x plus log of 5 raised to power x squared equals log of 3 plus log of 5, right? So log 3 raised to power x plus log 5 raised to power x squared equals log 3 plus log 5. What it means is that the left-hand side of the equation is equivalent, looks more comparable with the right hand of the equation. So the case 1, we take log 3 raised to power x to log 3. So if we do that, that's going to be our case 1. So we have log 3 raised to power x equals log 3. So our x is in front, so we have log 3 is equal to log 3. So divide both sides. Divide both sides by log 3. So if we do that, we have our x log 3 divided by log 3 equals log 3 divided by log 3. So this log 3 we cancel. What it means is that our x is equal to 1, which is actually equal to the first result for the method of simplification that we did. All right, case 2 again. So our case 2, we take log of 5 raised to power x squared against log of 5 at the other side of the equation. So we have our x squared log 5 is equal to log 5. Again, we divide both sides. Divide both sides by by log 5. And you can see it. It sounds interesting. So there's no stress here. So what we're going to do is we have x into log 5 divided by log 5 equals log 5 divided by log 5. Then we cancel both sides. Our x squared, right? So our x squared is equal to 1, right? And what it means that our x is equal to plus or minus square root of 1. Hence, our x is 1 or minus 1. And then we can conclude minus 1 is not part of the correct solution. The reason is because if we substitute to the mother equation, all right, if you rewrite the equation, all right, that is x cannot be equal to minus 1. The reason is because if you have 3 raised to power minus 1, substituting into the real equation 3 raised to power minus 1 or times 5 raised to power minus 1 all squared, this result is not going to give us 15. Therefore, minus 1 is not a correct result or solution for value of x. So x is 1. And if you substitute 1, it's going to produce 15. I hope you learned something. Please do check our other videos, all right, to watch some of our other excellent videos that will help you. All right, as you watch, you share our links, and then you give us a thumb up and you comment. If there are topics you want us to address, please do send them onto our learning platform. You are always at rest to get the best.